covering the design workflow, implementation workflow, and test workflow. And in previous video, we have already covered initiation workflow, the requirement workflow, and analysis workflow. So if you want to get a better hold on these workflows, then you should know about the previous flows. So I would recommend you to watch these video first. These video are like posted on my channel. You can go and watch there. Okay, so moving on to today's topic, first we are going with design workflow. So in design workflow, before I explain these bullet points to you, this is very important. In design workflow, we create the architecture and the design of the whole system. So architecture and design are two different things. This is very important to distinguish between them. Architecture is the high level structure, the big picture of the whole system. In this we'll see how is the system organized overall. The high level picture, we'll just implement this Microsoft. We will just implement it, like if what architecture are we using, whether it is a monolith architecture, and how components are connected to each other. In this we'll show the API. We have the API gateway. API gateway is connected to orchestration workflow, right? And orchestration workflow is then connected to other services which we need to call. And we'll also describe, like for example, we don't want if we want to keep a separate service that user can access, so we can also mention it here, like login goes without go like when it comes to orchestration. So when it comes to API gateway, when it fails, it goes to login service. We will show that how will the structure format, on what request what will happen. So this is the blueprint of the system, the whole blueprint of the system, the architecture of the system, how each service is connected. Now design is the low level structure, the detailed picture inside the structure. As we have mentioned, the example that I given you, in like we have the what did I say, we have the API gateway is connected to orchestration layer is then handling our flow of data, right? So now in design, we will implement how that API gateway will be implemented, what components, what classes would be there. So this is the low level design that will say how each component will talk to each other. Like in API gateway, obviously we won't just write a class and do everything. We will create separate classes and like describe how will they talk to each other and how will they talk to orchestration. So in design we will implement it. So this was very important. Now let's get to the point. Build product architecture. As I've already explained, we will build an architecture here. The overview that we can see, how will the system and the data will flow. Decide on platform. So here you will decide the software and hardware for your system. Software, if you are using like which programming languages, which framework we are using. Hardware, like which hardware is compatible with this, and like what changes do we made prior time before implementation to this workflow. So like this is not only handle here, the support process also plays a big role in deciding and version and everything. I'll explain that later when we'll go there. Giving all the information here is not relevant. So decide on the actor and interfaces. So this is the important point. We'll decide the actors. Actor are who will use the system. Actor are those. And interfaces are same, our component, our designs, our classes. So these are the points of it. So and in design workflow, we'll also build some criteria for testing. Build test criteria. So this is very important. You may look and say like this is the part of testing, but no, we will build the quality model and test criteria and a designing workflow is very crucial, because here we can make or break our end goal. We have gathered the best requirement, we have analyzed it and sorted it in a order. But if we'll make the designing principle wrong, or will use obsolete or any other classes, if we'll just hand it to the if we'll just use obsolete and other classes, then our whole system will fall down. In Like, it will run currently, it will run fine, but very soon, not very far, it will just collapse. So, build test criteria. What is this? What condition must be met for a component to pass? What is pass and what is fail? What is the boundary of a criteria? On, like, what boundary do we test it? So, like when we are testing something, how would we know, like, whether this testing went well or this testing fails? We'll decide this criteria. So if the system is running and it is being connected to system, and data flowing so very important, data flowing is like less than 1 second, which was our requirement, so then it is passed. If everything is working fine, but the data that we are receiving time is exceeded 1 second, like 2 or 3 seconds, which was not our case, so we'll consider that test a failed component. Even though our component is working fine, our test is working fine, and everything is working fine, but the time, the data receiving time exceeds the limit that we have set, mean the test fails. So we implemented it. Build test models. Now we'll build some test classes and some mock objects. Mock objects are build test model. Now we'll mock object build, like, are the stubs of the classes. So do the fourth point is all about that. I'll explain that there. Build test model, the plan, how test will be conducted, what will be tested, in which order it will be tested. We are modeling the test, like, if we have a component, so we'll say, like, first you should check whether the data is receiving on time or not. If that test pass, then only we should move to the next, then only we should test the next functionality of that function. We have set the priority, so first test this, test this, test this, test this. And also, in priority in test, it doesn't mean that every component should pass. That's called exhaustive testing. It means we should test and until everything fails. So if you're doing it manually, then this is not, I won't say impossible, nothing is impossible, but time waste. We test the test on scale. If the highest priority tests are being passed, then we should leave the lower priority one. So this is the priority we set in the test model. Quality models, this is important. Quality model define the quality standard a system should met. Its performance, its performance, its reliability, its security, its usability, and its fault tolerance. These are the things that our system and the component we have built should have. It should be fault tolerant, it should be reliable, it should be easy to use, it should provide security. So if any of it is failed, then it means we have failed our test. So that's the qualities that our component or system should have. These are must. Tool support, what kind of tool will we use to for above testing? Suppose we have used JUnit, Postman, etc. What tool we'll use, we'll decide here. Prepare test script and stubs. So this is important. Test scripts are written test cases define exactly what the test should do. Now this is the script. We'll prepare the script. This is the actual class that has been built, and we will just run it. And if the system is failing or passing, it depends on this. We have built the criteria, and this will be tested on criteria. And stubs, what are stubs? So we are above, I have mentioned Mockito object. Mock objects are something that are a replica of the real object, right? It won't, like, it will show as a real object, but it won't behave as a real object. We'll mock that object. it won't return anything unless we specifically told it to. But it will ensure a system that we have something here which is similar to the object you are trying to call. We'll create a stub, a mock that is not actually connected, but there. It won't give us real data. It will give us what we wanted it to be sent. We only use this when in unit testing, and also when we are testing the system, and the system we then the component that we wanted to test this component with is not ready, so we'll make a stop of it. Now moving on to the implementation workflow. This is where the actual coding begins. So far we have been just planning and designing and everything. Those are very important. Now we'll implement the code. Now we'll write our first line of code here. The point is build design component. Now the component that we have designed above, the classes, the components we have set above, now it's time to really implement them. Every component module that was described above now will be executed and will be in a actual shape. Unit test the component. So let me tell you, so before this point let me explain you something. So even though they are in a even though they fall the even though it is written that it is a, what do we say, non-repetitive, and what is that word I am forgetting, I with like so even though it is said like first we have to complete this flow other, and then we'll move to the next flow. There's a specific word for it which I am forgetting, never mind. So but in design, implementation and testing, that doesn't work. We do designing and testing parallelly, not actual testing. We'll design the test script in the designing workflow. So this was the part of testing, but we are doing it parallelly with design workflow because this suits here. And also the same thing is we are implementing the work, and as well as we are also testing it. We won't wait first to implement everything, then we'll test. It will waste all of our time. So what we'll do, first we'll implement it, and as well as we have implemented a component, we'll test it along the way. So this point is about that. And remember that implementation workflow and testing workflow run parallelly, but we have to mention that they come after that. So this is so that they come after that. I still can't remember that word. Unit testing the component. Now the component that we have built, we will unit test it. Unit testing is a kind of a testing that I'll make a specific video on it. It's a cool testing. It's a cool way of testing your components. Compile unit test result. Though the unit test that you have ran above on the component, now you will make a report of it. What that report will show, that report will validate all the quality models and criteria and the model of the test we have built above. If so, then we will consider our system a good system. Unless if not, then we'll just say our system wasn't on the right track. We'll make some changes in it. Now move to the testing workflow. Now implementation is done. In implementation workflow, we do unit testing. Now the actual testing in next flow would be testing workflow. Why did we do unit testing? Because unit testing doesn't require like, let me tell you, you will think like, when unit testing is also part of testing, why didn't we just test it in the testing workflow? So unit testing is not live testing. We don't use live component, live database, anything. We mock the object. I have explained above the stubs. We mock that object, we create stubs, and then we perform it just to check whether is it returning the desirable result that we want it. We will mock it. We won't actually run any live server, any live services right now. Even like when we have Kafka anything, we won't actually run it. They will be shut down. We will just test their behavior. How will they behave under those scenarios? That's why we did it here. Test workflow. This was important. this video is exceeding the time. I'm sorry, but this is very important for you to understand. If you want to understand, then what's the point? The test workflow, moving on, we have perform testing. Now, we have already performed some kind of testing in the implementation workflow, which was unit testing. But now here we will test. Now we will here we will do here we will do perform testing, means the test in which the live services are required, meaning our databases are up and running, our message brokers are up and running. We have to test those. So when in the performance in the perform test, when we do the perform testing, we usually do integration testing. Integration testing requires live server to run. We'll implement them and we'll see the behavior of the live server. How is it doing? How we are doing it. And system testing, test the entire system workflow, how the entire system is working within each another. User acceptance test, this is very important. So the client test if the system is what is expected. If it met their requirement, then only it will keep it, otherwise they will just ignore it. So that's very important. So this is the performance testing we are doing. Oh, so sorry for that delay. you know so report, test, analysis, and statistic, the last part. Now the test we have done, we'll create a test report and its stats, what how many tests are passed, and this these testing, right? Even though these testing will also follow the same quality models that we have built above, test criteria that we have built above. If these unit testing, system testing, any kind of testing, smoke testing, met the quality model that we have built, which mean our system is ready to be deployed in the next step, which I'll explain it in the upcoming video. So that's it for today. So before going, I would just say, please subscribe to the channel. you know I have closed my fan, and also I have closed the AC. I'm sitting in the open window just for you guys, because you said that the fan sound, the shuttering, the fan sound is very much, and it's annoying in video. So for you I'm doing this much, so the least you could do is just like and subscribe to this video. It will give me a boost in confidence, and I'll also post more of these videos. If you see any like misinformation or anything, if you have any comments, if you have any question, you can ask me in the comment. I'll surely reply to them. Thank you. Bye bye. Take care.